Hello, we are Group 3 and we are here to present our project, which is Gastrointestinal Disease Prediction. Our group has 5 members, namely Bhashya, Ayush, Nikhilesh, Gautam, and Shreya. Alright, so moving on, gastrointestinal diseases have become a widespread cause in the healthcare system right now, and it has caused a lot of discomfort to patients. So, by our project, we are trying to develop an image based machine learning tool which can help classify gastrointestinal diseases earlier so that we can take necessary precautions. We are trying to use 8 diseases. If you could move on to the next slide, please. Okay, so these are the first 4 diseases that we aim to classify, namely dyed lifted polyps, dyed resection margins, esophagitis, and normal cesium. And then we have the next 4 diseases, namely normal pylorus, normal Z-line polyps, and ulcerative colitis. So we try to find a data set, which is the KVASIR data set. It is a multi-class image data set which consists about 4,000 images with 500 images belonging to each of the 8 diseases, as I earlier mentioned. I'll show you a sample data set. Okay, so these are a couple of sample images from our data set. And now Bhasha will take over and explain the data processing part.
So our exploration showed us that all the images were of different sizes. So to normalize it, we reduced the image size to ensure reproducibility. And since our models required an RGB format and the images were in BGR format, we converted all of them to the RGB format with a function in Python. Go to the next slide. To make sure that our model understands the classes, we have label encoded each diseases and represented them by a label number. Okay, next slide. So in the methodologies, we have used HTML and CSS for our front end along with JavaScript. We have used the Flask framework for a backend and stored all our data in the Postgres database. We have used MetaLlama trained on 3.8 billion data as a LLM, which helps with the chatbot in our product. And the final model used is a DenseNet 121. We have used Jira and TeamGant for our Scrum tools and communicated with our teammates over Zoom and WhatsApp. Next slide, please. So this is the model which we have used in the final product. Unlike traditional neural convolution networks, DenseNet model has the layers connected with all the other layers, which is a unique point in the model. We have fine-tuned the model using global average pooling layer. This layer reduces the spatial dimensions of all our features. We use a dense layer configured with 256 units and a ReLU activation function. It has non-linearity to our classes. And we have used a dropout layer which randomly drops neurons to prevent overfitting. Okay, next slide, please. So in this, as you can see, we have achieved an accuracy of 90%, precision of 90%, and a recall of 90%. Okay, next slide. Over here, you can see that the product that the model still has a confusion between similar classes, that is 0 and 1, and it has a few rare misclassifications where it predicted the class 5 as class 2 and class 2 as class 5. Okay, next slide. In the ROC curve, you can see that the model is pretty accurate with diseases class 3, class 7, and class 4. Now Gautam will show you the demo of our product.
So for training the data set and everything, we have used VS Code and Jupyter extension. And also we have created the app and everything using Flask and Python. And this is the running app. So as soon as you enter, you go to the login page. And once you log in, it'll take you to a page where you can upload an image. So once you upload an image, it will give you the resulted section by
Uploaded a
running
file from
through
our
the.
dataset, and as you can see, it's classifying it correctly. And the product shows you a detailed information about the diseases which has been predicted,
So the disease that I
which is over here, it's a normal
added
Z-line.
was normal Z-line, and it gives the complete detailed information about the same.
If you scroll to the bottom, there's also a chatbot to which we can ask questions, additional questions if we have any more queries. This goes directly to Llama, and it takes some time, but we receive a response from it.
Yeah, so if you see, it has all the details, and also you can
As you can
chat
see,
with
we have
it.
received a response from Llama, and this concludes with our demonstration. Thank you for your time and attention.